Morning, guys. Hi, Kim. Hi, Ryan. Hi, Logan. Mason, Aiden, Logan, Frost. Miss Kilduff, how you doing? So, three things on the agenda today. Hi, Azra. We are going to do our DNA. That's been the same. It's down below. Yes, there are two parts to it. Okay. Second part of the agenda, we're going to review spring versus neap tide. No, that's not an assignment. No, it's not something you have to complete. Is it going to help you, especially on the weekly quiz and moving forward to a unit test next week or the week after? Yes, it is. All right. And then modeling eclipses, jumping to the next assignment, doing the explore section. If you've already opened it, you kind of already have an idea, but I'm going to go through just the very beginning, read a little bit about the eclipses, open up the simulator, show you how to allow it because it does run Flash. HTML5 is better. HTML5 is what a lot of your apps run on in Chrome, but this is an older simulator, but it's a good simulator and allow Flash for this. All right, don't normally allow Flash because it's a little unsecure. All right, and then there are several questions in the Explorer, but each question kind of guides you in using the simulator to look at solar eclipses and lunar eclipses and knowing the difference between them. All right, so you're kind of working along with us. First thing on that agenda is doing DNA number 3. What is high tide? What is spring tide? Okay. Provide the sun, earth, and moon alignments for both of them. Again, you are putting that right in your sheet. And box number 3, you can type it out. The alignment, you can describe it or you can draw it and put it down below where you put your diagram yesterday. But that's not required. I'll go over that at the end of our stream. I'll draw it out for you, write it out for you. So it's part of the stream, and then we have a series of notes for tonight. Hi, Cole. Hi, Ella. If you're Hi, Hayden. Miss Kildoff, the only way you can really track who's in there is if you guys are in chat right now. I can see who's in there. But we got, I don't know, quick count it. We got 11 people in the chat, and there's 19 people watching. So there's people who can't join a chat but are still watching because of an account restriction. Yeah, there's 19 watching, but there's only like 11 in the chat. So I can't tell who the other viewers are. It could be anybody. Probably other students who can't join the chat because the Coventry account doesn't allow them to join chat. I've been talking to Miss Norbelucci and IT to get that maybe fixed. Hi, Kaylee. But again, that goes for if you are watching, you're not in the chat, you can ask a question through email or Remind. Remind's a little slow right now. I know someone sent something, but it's not loading. They're under high server strain, like all the other services are. If you guys remember back at the beginning of the year, servers basically what the internet is, right? Computers that store information. So reminds servers, wherever they are in the United States, a lot of people trying to connect to them, makes connections slow. A lot of teachers using it right now. Hi, Troy. Hi, Jack. Yeah, see, so there's an example killed off. Jack is using a personal account, using his home account. He's not using the school account because school accounts won't let him into the chat. So we're working on the DNA. What is high tide? What is spring tide? Provide the sun alignments for both. I'll go over that towards the end. Kind of come back to that full circle. I'm going to go over the special tides in a couple minutes. Spring versus neap. So we have high tides, we have low tides, but then throughout the month we have special tides. Tides where they're really extreme, where high tide is higher, low tide is lower. And then we have tides which are more minimal. They have very small difference. High tide is actually lower than normal, and low tide is actually higher than normal. So when do those situations happen? You need a special alignment, just like you need an alignment for regular high tide. Alright, so I was finally able to see the remind on my phone instead of computer. Why does the full moon create extreme tides on the Earth? Well, that's what we're going to talk about in a couple seconds. Did we have an eclipse last night with the new moon? No, you didn't. Because the new moon is only out during the day. It's out from 6 in the morning to 6 at night. So you can't have a solar eclipse at night. The new moon can make a solar eclipse, as you're going to find out in modeling eclipses. It's the only time you'll ever see the new moon. That's incredibly rare because you have to have a certain number of variables all line up for the perfect opportunity. Those variables are in the simulator that you'll see later today. So I'm going to kind of transition over to spring versus neap. If you guys are good, we'll come back to that DNA if you still need a little more time or you want to check yourself. All right. Go to roll tide again, which most of you turned in last night, which is pretty good. Looking at this title data here again. Last time we'll really take a look at this assignment and this picture. Now you're probably getting sick of it, but you can see through Watch Hill, again, the most southwestern part of Rhode Island. I wanted to pick a place that wasn't really near the bay, wasn't affected by the bay, open to the Atlantic, and some place of, where you might have maybe heard of or at least been. All right, so picked Watch Hill in February. We're not looking at March. All right, and you can see the crests throughout each day is a high tide. The troughs, the low parts, are a low tide. So tidal height, sea level throughout the day. There are 4 tides in a day. They alternate high, low, or you can picture it as low, high, low, high. All right. Some days kind of get cut off at midnight, like the 6th only has 3 tides technically, but it's still alternating high, low, high, low. All right. Just a little bit after midnight from the 6th to the 7th of February last month. All right. So what I wanted you to take a look at for this assignment and then moving forward is understanding that the moon has an effect on the tides. So we talked a little bit about just how high tide works. All right. But then there are extreme tides here from the 9th to the 14th and 15th, almost that whole week. And then there's tides that are pretty minimal from like the 2nd to the 4th, 1st to the 4th, right? So this is your neap tide, your more minimal tide, okay? 9 to 13 is your spring tide, all right? Why they happen is dependent on the phases. So I got a question through Remind earlier. Why does the full moon cause an extreme tide? Why does the full moon cause a spring tide? It's because of the alignment. All right, so let's talk about the alignment. Again, the 9th to the 11th near the full moon. This is for February, right? So what are we looking at? Make that a little thicker, and let's do that so you can actually see well. In a spring tide, you need a perfect alignment of the sun, the earth, and moon. All right? The combined gravity of the sun and moon creates a higher high tide and a lower low tide. So more extreme tides. Okay? So spring tide need a perfect alignment of the sun, earth, and moon. The combined gravity of the sun and moon creates a higher high tide and a lower low tide. These are more extreme tides. So this is where you see, again, throughout the month, periods where the tides get a little more extreme or a little more minimal. All right, and it's alternating. And there's 4 phases that alternate that we're going to look at: full moon, new moon, first quarter, third quarter. So those are the 4 main phases that are going to kind of dictate what kind of tide that we have in terms of a spring or a neap. So the special tides. All right. So you get a perfect alignment. The sun and the earth relatively are going to be in the same spot. Earth's moving around the sun, sun's moving around the center of the galaxy, but to our vantage point, it's stationary. The moon is the one that's going to be moving the most in this whole relationship, right? So to make a perfect alignment, you need the moon to be either here, or you need the moon to be behind the Earth, over here. Okay? That creates a perfect line. What does this do for the tides? Well, it kind of picture from yesterday. Water gets pulled to the moon. Not all of it can get pulled over to the moon. This water moves over there. This water moves over here. This creates high tide. This creates high tide. This is low tide. This is low tide. Where would the sun's high tide and low tide be? The sun has an effect on the tides. It's just a very small effect. So if we didn't have the moon, we'd still have tides, just very small tides. And those tides here with the sun and the moon, the sun's tides would be, again, right here, the closest side. And then the back side would be high tide because it can't reach all the way back around. All right. Low tide would be where the low tides are for the moon. If low tide and high tide and high tide match up, then you're going to have extreme tides. The same thing happens up above. Moon's high tide. This water gets pulled this way, which leaves not much water here, so that's low tide. Okay? Matches up with the sun, because that's the sun's closest side here. Furthest side for the sun. The sun's pulling water again to where the moon is anyway, so that's low tide. I wrote that as high tide. And this is where you get spring tide. Okay? Now, the phases don't cause spring tide, neap tide. The phases are going to relate to where the moon is. So here, the moon is moving in a counterclockwise orbit, revolution. The phase closest to the sun, that's going to be new moon. The phase opposite the sun, and opposite new moon is going to be full moon. So yesterday morning at 5 in the morning was new moon for March. Therefore, we had a spring tide yesterday. The tides were spring, which means low tide was lower, high tide was higher. Any questions so far on that? Again, email, remind, or an appropriate use of chat. Yes, talking to some of you in there. Can be used to ask questions. So if this is top down, will a different phase cause a different reaction? Yes. And thanks for reminding me that this is top down, Rainy, because I'm going to put our axis in here. This is top down. I'm not drawing the axis diagonally because that would be side view. This is top down. That's a little too big. It's going to blot things out. Again, it's off center because there's a tilt in our axis, right? Hi, Gian. The other side now. So Jacob asks, is there going to be a different reaction if a different phase? Yes, there is. We're going to talk about first and third quarter. All right. What happens when the sun, earth, and moon are at a right angle? They make a right angle instead of a perfect line. All right. So neap tide. Okay. Jack says, are spring tide and high tide the same, or is spring tide a stronger version of high tide? Spring tide and neap tide, spring tide and high tide, sorry, are going to happen under the same moon alignment, in that you and the moon and the earth are in a straight line. If it's the sun, the moon, the earth, and you in a straight line, you'll have a higher than normal high tide, because now the moon is combining with the sun's gravity to pull more water to your area. That's going to make tides higher. So, is it the same thing, spring and high? No. Is spring a stronger version of the high tide? Yes. Spring tide is just a more, it's a different, it's a further category. So for a neap tide, there needs to be a right angle the L, 90 degrees. You need a right angle alignment of, again, the sun, earth, and moon. The gravity of the sun cancels some of the moon's impact on tides. This makes a lower high tide and a higher low tide. Yes, you can make another one, Ryan. Gian, this is just extra notes. This is extra review. If you want to put it on the DNA sheet for your reference, I'd put it at the bottom. It's very similar to what we talked about yesterday. Just further review. Yeah, it was Gian, Hayden, and John. Hayden. So when I said extreme and minimal, or maximum and minimal tides, this is what I'm referring to here. Extreme, and this makes tides more minimal. It wouldn't hurt to make this drawing, Hayden. I would put it at the bottom of the DNA sheet as like further notes. Again, I'm going to update the DNA sheet for next week. It's going to have a science notebook box, since we left our science notebooks in school. So I'm going to make that box somewhere in the DNA sheet above or below the guidelines. All right. I would suggest you make it, or at least just pay attention, understand it, be able to draw it on yourself, because it's going to help you for the weekly quiz. All right. But I'm going to come back to this in a second. I'm going to get to that in a second, Hayden. In roll tide, this is where you're seeing the neap tide from the 1st to the 4th. And then there's another minimal tide right there, 17, 18. Almost, not really the 19, but like 17, 18 is pretty minimal. All right. So 1, 2, and 3, you have first quarter. All right. Third quarter happens 15, 16, 14, 15, 16, 14, 15, 16. Again, that minimal tide. So the quarters seem to correlate with those minimal tides. They don't cause them. It's the moon that causes them with their alignment. But lunar phases tell us the position of where the moon is. So it's called correlation. All right? Phases don't cause the tides. They correlate with the tides. The moon causes the tides, and lunar phases tell us where the moon is. So it's called correlation. All right? Not causation, even though it's indirectly going to lead to the cause. So kind of just quickly diagram this, and then we'll move on to eclipses since some people are asking questions about it. Again, the sun and the earth relatively are going to stay in this one spot. I could change the spot, it doesn't matter, but just for simplicity to see the comparison easier. I don't want to exit out of your sharing your screen because it closed it out last time when I was trying to set it up this morning. So I'm going to leave that there for now. Sorry. I'm going to draw the moon up here. I ran out of space. Let's try this. I'm going to set up a little differently from the last one. So there's our two separate Sun-Earth moons. All right. Moon is moving counterclockwise. Where are the tides now? Well, for the moon, in the same spot. High tide is closest to the moon. And opposite the moon, because the moon can't reach all the way around, and because our tides change every 12 hours. Okay? So where would high tide and low tide be if you were thinking about the sun? The sun's high tide would be in there. So when the sun and the moon work opposite each other, because they're at a right angle, you're going to have a weaker than normal tide. You're going to have a lower high tide, you're going to have a higher low tide. Okay? Same thing over here in this right side diagram. The sun, yes, the sun is continuing to have that high tide opposite the moon. So now, what phases are we looking at? So Jacob wanted to know, do these cause different effects? Yes, they do. Different phases correlate with different effects. Okay, so this right here would be if we're going 1/4 in our orbit. So this new moon was over here. We're going 1/4. This is obviously going to be first quarter. That half moon, right? The right side is daytime, so the right side's waxing. And then if you go 3/4 of the orbit, opposite it is 1/3. Right? Half moon again, but this time it's waning on the right side. So the right side is in darkness. Okay? So some questions. Rosalind's doing really well. Thank you. Okay. Would it be high tide everywhere then? No, it would not be high tide everywhere, Rainy, because the sun, even though it has some kind of effect on our tides, is too far away, and so the effect that it does have is small. So our low tides are just higher than normal because that amount of water that's higher in the low tide is coming from the sun pulling back against the moon. Okay? Is the yellow colored HT the sun's high tide? Yes, it is. And so the yellow fills in what's missing with the blue, and that's why you see more around the planet because it's a mix. Because again, the gravity of the sun is canceling some of the moon's impact on tides, so the sun is pulling back. Somebody had a question on number 4 of eclipses. We'll get to that in a second. I know someone had a question about number 7 of the eclipse explore section. We'll get to that in just a second too. Just want to make sure you guys are good here. Because this is probably the harder parts of tides, understanding spring and neap. It's gonna be on your unit tests in about a week and a half. It's gonna come up again. This alignment, know the alignments for your weekly quiz. All right. So I just want to make sure you're prepared. It's hard. I only see 21 of you, 20 of you in stream. I want to make sure everyone's getting the right information. So I know not everybody can be here at the same time, but I just want to make sure we're good to move on. So it was a review. Did you need to write it down? No. Would it help you? Absolutely. Just want to make sure you're good. Get there in a second, Hayden. So when a neap tide occurs, we lose a difference in amount for high tide. So yeah, so the amount of water that normally builds up for a high tide would get displaced over to a low tide area. So a quarter of the way around the planet. So you can't create or destroy matter. So yes, the amount of water that you'd normally see during a spring tide, high tide, that extra amount of water is what gets placed on a neap tide, low tide. It's a lot of words. Hopefully that makes sense. Again, the amount of water that you see extra in a spring tide, high tide, the higher high tide, that extra water would end up being put towards a neap tide, low tide, because the sun and the moon are working opposite at a right angle. And I forgot to actually draw that in as some dots. I think helps you see. .90 degrees. Okay. How many unit tests do you have left? You have the Sun Earth Moon unit test. The units aren't as long as the weather units were, so they're going to have a little more than I think you expect. You're going to have the Sun, Earth, Moon unit test. You're going to have the Universe, Galaxy, and Solar System unit test, UGSS test, and then depending on how far we get into geology, plate tectonics, then we'll have maybe a unit test on that as well. So you're looking at 3 left. Not as long as the influences on weather and climate tests. That was a big unit and it was broken into 2 parts. All right. So, modeling eclipses. All right, Ryan's good. Zoom out just a little bit. This is the last phenomenon that we're going to be talking about. We've talked about day and night. We've talked about seasons. We've talked about tides. We're talking about eclipses. Okay, this is the last kind of thing that you see in nature with the sun, earth, and moon. All right. This right here is just a time lapse, but not so time lapse in that it's showing you like an animation. It's just showing you the position of the sun and the moon during a solar eclipse. All right. So this is a solar eclipse. This is the moon moving in between the earth and the sun, this shadow. So you're almost seeing the sun wane, which is pretty interesting. And then you have totality. Totality is when one object completely eclipses or blocks, obscures another object. And then the moon continues to move in its orbit, and the sun starts waxing, and then you have the same situation that you normally have all the time. Common question is, are you supposed to look at you're not supposed to look at the sun and the moon during a solar eclipse. You're not supposed to look at the sun at any time. The sun's not any different. Okay, just more people are looking up because something really rare and really cool is happening in the sky. Okay, so the sun's no more stronger, weaker, more dangerous, less dangerous during an eclipse. It's the same amount of danger, and also it's dangerous because, like I've said in class, I mean, your retinas don't have pain receptors. You're not going to feel your eyes burn. So even if you're staring at the sun, I don't feel anything. That's because, yeah, you're not going to. All right. The word eclipse literally means to obscure a block. With the Earth and the Moon in constant revolution, the potential for one object obscuring the other object's view of the Sun exists. Okay, so during new moon and full moon, you want to have the moon in between the Earth and the Sun, and you want to have the moon behind the Earth with the Sun. All right, you can only have an eclipse in that perfect alignment. So you can only really have an eclipse, if I go back here, during this time when you have a spring tide and a neap tide. This right here could be a diagram for an eclipse if I drew in lights and shadows. Okay. John asks, what would happen if the moon orbit the opposite direction? Well, then your phases would happen in opposite direction. The quarters, new moon and full moon, would still cause a spring tide and neap tide at the same spots. It's just new moon would be called full moon and full moon would be called new moon. That's it. Just like if you flip the axis on the Earth, you just flip the seasons, right? Instead of going into spring right now, we'd be going into autumn. So nothing bad? No, I would say bad. I know some people asked in yesterday's chat what would happen if the moon blew up. I think I want to explore that in a video because that's something very interesting I think would happen. You're not just going to have the moon spontaneously blow up. I think something cool would result from it, but something bad in terms of life on this planet. All right? Kind of look a little bit like Saturn, I think. So now the simulator. So again, straight line alignment. I click this link, and it can click anywhere. The whole thing is just one link. Open up the simulator. All right, and this is kind of what you see if you're running into this problem. And those of you watching the stream, this is good that you're here because I guarantee you other people are going to have an issue. All right, Flash is blocked. Flash is blocked by default anyway because Flash isn't very secure. HTML5 is better. Most of your games and things like that run off of HTML5. Okay, it also prevents you guys from playing games in school too because a lot of Flash games exist. So this puzzle piece right here in the URL at the top, there's a little puzzle piece with like a little red box in it with an X. Okay, Flash was blocked on this page. All right, well, can I just fix it just for right now? I click it. I get two options. I can manage or I can click done. I'm going to click manage. Under this setting, block sites from running Flash. It's recommended. I understand it's recommended, but I just want to use this one simulator that's really good to use to show eclipses. So I click the little button. Make it go blue. Close out of it. Go back. Okay. Refresh. And now instead of saying it's blocked, it says click to enable Adobe Flash Player. Okay. I click it. Now it says allow or block. I want to allow it. Boom. There's the simulator. All right. So you have to allow Flash just for this one time. I think it goes back to blocking it by default, which is good. All right. The simulator runs on its own. All right. In the left side, you see a top view, side view. All right. You see the moon is moving in its counterclockwise orbit. The nodes are just the halfway points. As soon as the moon crosses the node, instead of seeing the view of the sun from the Earth, I can actually click and drag it, you'll switch to view of space from the Earth. And then you'll eventually see something happen with the moon. All right. Just like you would with the sun. So the moon will run on its own, or you can click and you can drag it. Okay, pretty interesting. It'll tell you the phase of the moon right here. This is a waxing crescent. All the diagrams that we've done in class, back in school, in the classroom, we had the sun on the left. But you can put the sun on the right, it doesn't matter. If it's moving counterclockwise and just past the sun, it's going to be automatically waxing crescent. First quarter, gibbous, full moon, waning gibbous, third quarter, waning crescent, new moon. Okay, so the phases are right here. You can pause the simulator by checking the box, so you can slow it down if you want. All right. Outlines, I'm not quite sure what outlines do. Shows you the umbra, which is the direct shadow of the Earth, which we'll talk about in a second. All right. Keep in mind this is not drawn to scale, and penumbra is not shown. What's the penumbra? Penumbra is indirect shadow. Umbra is direct shadow. So just like we have direct indirect light, we can have direct indirect shadow. Okay, and when we diagram eclipses, just like we diagram tides a little later, then you're going to kind of see where the penumbra and umbra kind of are involved in an eclipse. There are three variables to use. There's tilt of the moon's orbit. There is the Earth-Moon distance, so you can make the moon go out further in its orbit, or you can make it come in closer to the Earth. All right, and then you can change the size of the moon. You can make it bigger, you can make it smaller. All right, so if you look at tilt, I can tilt it positive, or I can tilt it negative. And you see from the side view that changing the angle is going to change where the moon is in the orbit around the Earth. Put it at 0, it's completely in line with it, completely flat. All right, you go to 5 degrees, it's tilted down. -5 is tilted down the other way. All right, so negative and positive just means opposite directions there. Earth-Moon distance, you can spread out or close in the orbit of the moon. Okay, and then size of the moon, just make it bigger, make it smaller. All right, so just different things in the simulator because these questions are going to relate back to it. Okay. The simulator of the Sun, Earth, Moon system provides a way to visualize eclipses. There's a top-down view and a side view from space. There's also a view from the Earth, of the Sun from the Earth, and a view of space from the Earth that flips back and forth. All right, so kind of already went through that. A solar eclipse is when the moon casts its direct shadow or umbra on the Earth. You'll see that here. That's what this little black cone is. It's the direct shadow. When that cone falls on the Earth, where that little triangle is, that's you. The blue triangle's you. Then you're going to see an eclipse because the shadow's over you. You don't see an eclipse if the shadow's not over you. All right. A lunar eclipse is when the moon moves into the Earth's direct shadow, the Earth's umbra. So you are here at the blue triangle. You see the moon now inside the Earth's shadow. All right. And then you answer the following questions. Where's the moon during a solar eclipse? Where's the moon during a lunar eclipse? All right. During totality, which has a longer totality. So which one lasts longer, a solar eclipse or a lunar eclipse? All right. 3, what is the phase of the moon during a solar eclipse? What is the phase during a lunar eclipse? If you've been paying attention, you should probably be able to answer that. 4, why do phases make an eclipse possible? Again, think about first and third quarter. 5 and 6, you start changing the tilt of the moon's orbit. All right. 7 and 8, before you go to 7 and 8, reset this back to default. Somebody asked me that through email. Just want you to make sure that you reset this back to default. So you just refresh it, and it should go back to default. So don't set the distance and leave it at -3. Get everything back to 0 or back to default the way it was. Refresh it, clear out your changes. Now change the distance to 353,100,000 kilometers. All right. So for example, this, you're answering number 6. Try and get as close as you can. All right. Answer the question. Don't then go to 353 and then answer the question that way. All right. Do not do that. Instead, you want to refresh, and now you can change the distance. All right, and observe the effect. Okay. Same thing for 8 and 9. Refresh after 7. Do 8 and 9. I'm sorry. Refresh after 8, then do 9 and 10 in terms of the size of the moon. All right? And that's what you're working on your own today. If you have questions, all right, you can send it through email, remind, comments on the stream, all right, to help you. All right? You are only doing the explore section. All right? So Ryan's asking, when's this due? Depends on how far we get, if anything comes up. All right? Probably do the explore today. Review it, do the explain tomorrow. Okay? And then save the extend and evaluate for Monday. So this is probably going to be due Monday or Tuesday at midnight. All right? Probably leaning towards Monday. But as of right now, just focus on getting the explore section done. I'll put a due date in Classroom, and I'll obviously let you guys know when it's due. All right? Focus on the explore section right now for today. There's 10 questions, but again, it shouldn't be that difficult if you're just looking carefully to the simulator. All right? And a couple of them just repeat about the same variable. So 2 of them kind of match. One's like part A and part B, if you want to think of it that way. All right? So that's eclipses. Any other questions? All right. So I'm going to transition to last part. It's not on the agenda, but last part that we're going to do, and that's just going over the DNA question, and then I'll post a link to the stream into Classroom, okay? And these notes will be posted in Classroom towards the end of the day anyway, all right? So the DNA question, sure you have it answered. If you want to correct it, you want to add to it, definitely do it. What is high tide? What is spring tide? Provide the SEM alignments for both, all right? What's high tide? What is spring tide? High tide increase in sea level due to the moon's gravity. There are 2 per day with a low tide in between. Takes 12 hours to go from high tide to high tide. Good summary. Don't assume my agenda is gender. I moved it out of the way. Yeah, I hope we're going back to school. Zombie. I don't know who we are. Sorry. What would happen if the moon stopped rotating, Logan? Then you would see different sides of the moon. If you mean revolving, it would need to have a cataclysmic collision in order to stop moving. Because an object in motion stays in motion. So what's the alignment? To have a high tide, you gotta have a perfect alignment. I'm not going to draw the sun in because I don't want to confuse you. Low tide is the absence of that water. All right, spring tide. Kind of just go back to those notes before. Due to the alignment of the sun, earth, and moon, due to the alignment of the sun, earth, and moon, the sun and moon's combined gravity create a higher high tide, and that water's got to come from somewhere, so a lower low tide. What's that look like from space again? I'm just going to draw one example to save some time, because you guys are going to have to transition over to another class soon. Sun, Earth. We're going to make that moon full moon. Full moon again because it's opposite the sun. New moon's closer to the sun. Where's high tide at? For the moon, it's right here. Pulling that water over. High tide, low tide, low tide. That's all for the moon. How about the sun? Well, the sun would then also be pulling. Oops, I made that yellow. Sun's also pulling a little bit this way. Building up over here. High tide, low tide, low tide. So again, the sun. So the sun does have an effect on the tides. Keep that in mind. The sun does have an effect. It has such large mass, such large size that its gravity does have an impact on the tides. However, the moon has the larger impact because it is closer. Okay? But however, when both are in alignment, they both work together, and it makes a larger than normal tide, or a small than normal tide if you're talking high and low tide. All right? If I delete the notification, I'm probably going to make this stop. I'm going to get rid of it and take a screenshot for you later today. Because there's no way. Oh, there we go. Get rid of it. You're welcome. Rainy, is there anything other than eclipse? Anything other than eclipses that occur with a right angle? You would just have your first and third quarter. That's really it. Will the notes be on Classroom? I'll be posting different notes. The Thursday notes before your Friday quiz, I'll be posting those as normal. Okay? Got rid of the notification. Thank you, Azra. The stream gets archived on his channel. I don't think anybody asked, but thanks, John. Okay, thanks. Yes, thanks. John, you playing today after we do the work. Okay, wonderful. Are there any other questions? Is it going to be on Classroom? Yes, the notes are going to be on Classroom. The screenshots will eventually be on Classroom, but I'm going to post a link to the YouTube stream like I did yesterday, part of the daily post. The daily post will have a link to this stream if you want to go back, rewind, rewatch, do whatever you need to do. All right. Any final questions about science? Her name's Rosalind Hayden. So tomorrow we'll work in the explain section of Modeling Eclipses. We'll have one more DNA to do. It'll be about low tide and neap tide. And probably start diagramming a little bit what the eclipses are in terms of solar and lunar eclipse. All right, that'll probably be the second part for tomorrow, just like how it was for today. Okay, so this is today. Finishing that DNA, make sure it's updated. I'll post a link down here as a comment to the stream in case you want to rewatch it. All right, make sure the explore section of my eclipses is done. Make sure that you check for notes later on Thursday. All right, and if you also want to take a look, I did post links. I used a webcam for a resort at Myrtle Beach, Palm Resort. I don't know. I just looked up different webcams trying to find someplace, relative famous that I could find. This is Myrtle Beach on the 22nd, a couple days ago. It's low tide at 3:40 p.m. Okay, I took it at 4:03, so it's 20 minutes after. All right, and then the next day, 9:05 in the morning was high tide. I took it at 9:13. So you can see, if you use the pier, that there is a clear increase in sea level and a decrease in sea level. All right, so it's kind of cool visual. All right, you can obviously Google webcams for different resorts and see what the tides are at that time. All right. All right. Got any other questions? Email them or send them over Remind. I'll see you guys tomorrow. Bye, Azra. Bye, Ryan. Bye, Gian.